Hey everybody, Dr. Tracy here, and I wanted to talk a little bit today about graphics and audio for mobile games, which is the chapter that we are covering this week. So, if you are following along, I did post this PowerPoint on Canvas and you can find it. Typo, ooh, icky. Uh, Mobile game graphics are a necessity to create appealing games. And so, most often with mobile games, 2D graphics are used. There's a really good reason for that. While 3D graphics are best used on consoles and even gaming on the PC, most mobile devices have less storage availability and less memory. And so it makes it easier to play with the smaller graphics that don't have to depend on a third criteria of having 3 dimensions. So they're easier to play, they require less computational power, and they rely on simple mechanics. So let's talk about graphics a little bit. There are 2 types of graphics, pixels and vectors. So the difference between pixels and vectors are, in a nutshell, pixels are dots. They're made up of a whole bunch of dots, and when you zoom out, it looks like a picture that's drawn. You can use pixels. There's lots of different pixel software. If you use something like Paint or whatever, you're drawing by dots, and everything that you use is going to be by dots. Now, the closer you zoom into it, you start to see those dots, and it looks jagged. This is why pixel art can't be scaled. It needs to be the size that it's created at and zoomed out to be able to view it as an image. Vectors are different. Vectors are easily scaled because basically vectors are graphics that are built according to the mathematical calculations to redraw them. So for the most part, the size of a image is only dependent on the scale that it's created at, because each time the image is displayed, it's redrawn. The different file formats that you would see, if you see something called raster graphics, raster is another word for pixels, because raster is going to rely on basically dots, picture elements. That's what pixels is short for. There are different types: JPEG, TIFF, RAW, GIF, bitmap, PNG. More than anything, you're going to see things like GIF, JPEG, and PNG. And they each have different things that they are really good at. The JPEGs are good for pictures. The way that they use compression to make the image smaller is by getting rid of the colors that aren't being used and establishing shades of colors that already exist by reducing the white or black that's mixed with it. GIFs, on the other hand, they use less colors. GIFs are typically used for things that you don't care about the quality of the graphic, but you want to have, you can use animation or moving images. Portable network graphics are very similar to JPEG and GIF, but they don't do the animation. Now, vector graphics are computer graphic metafiles, and it's not likely that these are something that you'll share, but they're run as part of a program. So in other words, a program that might create the vector will have coding rather than saving the image itself. So the file formats for vectors are going to be much different. And then, of course, for video formats, there's MPEG, QuickTime. Different software that you might use to create your graphics images: Photoshop, Debabbilizer, new GIMP. If you haven't used GIMP, oh, that should be in. I don't know why. Typos everywhere. Flash, 3D Studio, Milkshake, Blender. Some of these are free, some of these are for cost, some of these have free trials. There are resolution issues as you start working with graphics, and that is that when you have to think about older phones versus newer phones or tablets, having to figure out what size you want to create your game sometimes means you might need to have multiple versions of the same graphic. When you create graphics for your game, we call them sprites. Sprites are objects that have a role within the gameplay, and usually they consist of one or multiple graphics or a single sheet that has key frames representative positions of that game object where it can be manipulated. It's kind of like a cartoon in a sense when you make something animated, because you just show different pieces of a picture. If you have an animation of somebody walking, you might just have a picture of left foot forward, feet together, right foot forward, feet together. And then when you display all four of those pictures in order with a little bit of change, it looks like something's walking in your game. Well, the same thing is done when you create sprites. What you do is you create a sprite that has either multiple pictures or a single image that has several individual frames associated with it, and you change the code to describe the way and how it will be displayed. Other assets for your game are the backgrounds. What's going to look in the back, and is it fixed or scrolling, horizontal or vertical? Now, as you're thinking about your next project and what you're going to do with it, you want to start thinking about the graphics that you'll have for your game. And that includes not just the main character, but also things like stuff that's going to be in the background, non-playable characters, images or assets or things that might be picked up or touched or interacted with, weapons, bullets, all of those things. Where are they going to come from, and how are you going to display them? Sometimes background images are displayed in tiles, which are images that are cut so they can be put close to each other and repeated. And when you have a tile set, you can create a whole game with your list of tile set and change it up to have differing backgrounds. Parallaxing is a term that means we have different images on different layers and we move them at a different pace. So if you're ever driving down the freeway and you look at the mountains don't seem to move, and it doesn't seem like you're going very fast. But signs on the signpost on the road fly past your car. That same thing can be put into a video game with parallaxing. We just have an image that's way in the back that doesn't scroll as fast as an image that might be in the front. Other graphics techniques are masking, where we display only parts of the image. And sometimes that's necessary to demonstrate that something is behind something else. So since we don't actually have a behind and in front of, we sort of put it in a way to make it look that way. Another technique is using alpha for transparency to make things visible and not visible. Sometimes stuff is put into the scene because it needs to be there, and until it's enacted upon, we don't need to see it. Sometimes there's objects that have to be included, but you can't see them until some event happens within the game. When you're working with 3D graphic assets, there's much more to consider than just the type and the width and height or whatever, or whether they're dots or vectors. Because when you're working with graphic assets, we have to create 3D models. And the 3D models or wire models kind of define the way that a model is. And each one of those connected shapes is a polygon. So we start looking at graphic assets in 3D, whether they are high poly or low poly, meaning are they very smooth with lots of tiny little shapes that make up the total of that, or are they very clunky, boxy? You can see the edges. Once you create these models, then you add this mesh to them and texture them. That means that we add pictures for them to show what they look like a face or a jacket or a color or something that looks like wood to wrap around a box or whatever. A bump map is something that's used as a wire texture to create a level or hills, mountains, or how something is going to be mapped. And so these are just things that you would use when you're working with 3D graphics. For this class, we're sticking with 2D, but you should at least be familiar with these terms. Audio. In the next chapter, the first chapter to read this week is graphics. The second one is audio. And in audio, the other thing you should be thinking about in your game is what you are going to use as far as sound. And so some of the terms that are discussed in these chapters are how to use sound and what the words around there, like MIDI, analog, digital, sample rate, word length, compression. These are all things that have to do with audio. I don't mind if you get sound from somewhere else and use it, as long as you give credit to where it came from. But there are things that you can do to create your own sound, record it, and save it in files that you can use within your game. So the types of game sounds that you want to think about for the games that you're creating are dynamic audio. What are the sounds that respond to gameplay? And this could be adaptive or interactive. Adaptive, an example of that would be, as the time's running out, the music gets faster. Interactive means when I shoot the gun, I hear a boom. So non-dynamic would be like the opening scene, you can't change it. Different kinds of sounds like diegetic noises. You might just have, okay, if you have a game that takes place at night, maybe hearing crickets, maybe hearing, an owl or whatever, the kinds of sounds that just might make you feel more immersed in the game. So these are things to consider as you're creating your game sounds. When you create your idea for your mobile game, make sure to include what sounds you want to use and find them or record them yourself. There's a few different audio editing software. I really recommend Audacity. Audacity, if you have a microphone, works very well. It's also free, and I've used it a lot myself. Some of the other ones like Ableton, they cost more money, and professionals within the sound industry would probably tell you Audacity isn't enough, but I think it is. Anyway, so there's the stuff for this week. I hope that's helpful to you, and I will talk to you next week. Thanks.